Welcome to my first tutorial ever. Who am I? I am the guy who made this image, posted it on Reddit and got a bunch of upvotes and also a lot of questions about how the hell I made this in Worldmachine. I also made this one later on, and both of the posts gained like incredible amounts of upvotes relative to the other posts. So I felt like, yeah, why not make a tutorial, because people were asking for it. First of all, my English is, I don't know, adequate. English is not my main language, so I'm going to try to stumble and mumble my way through this tutorial. Also, I'm recording, simulating and doing everything on this laptop, so I'm going to be pausing and resuming the recording several times, just because I don't want you to sit through the simulation times. Yeah, so what we're going to go through, we're going to go through how to generate and export Worldmachine geometry. Then we're going to move it into Cinema 4D, export it to Octane standalone, since I'm not using the Cinema 4D plugin yet. And then we're going to render out a PNG image and bring it into After Effects, which is my choice of color grading, color correcting software. I'm going to tell you why I'm not using Photoshop for these kind of images later on. So, first of all, let's jump into Worldmachine. And if you've already used Worldmachine before, you're going to be familiar with the layout, but I'm going to do this for anyone who wants to learn about Worldmachine and what it does. So I'm going to go through the most important steps. Alright, so here is Worldmachine. No base program, software, whatever. I'm just going to go ahead and delete all these, and if you try to delete them by just using the delete button, you're going to go in like crazy like me after a while, because if you press it, it asks you if you want to delete it, and you have to accept it. Just use shift delete instead, it goes faster, go away already. Alright, so up here is your device view. This is where you have all your nodes, and you connect the nodes to each other and you do stuff. And then we have the preview views as well. So if I just put a random geometry object in here and I check the different views, you have a layout view which shows the basically the world, and this little square right here is where our geometry cube square area is going to be. Then we have the explorer view. I never use this because it's confusing, period. 2D view is great for checking out your textures from top view. And then finally we have the 3D view, which is the one I use the most because it combines the mesh height data and the textures, and it just is intuitive for me. Right. If you go to the device view, you're going to have all your tools, generators, filters and stuff. And the generators are naturally generating geometry. The filters are just as in Photoshop. A few of them works like that. Yeah, you have bias gain, you've got curves, you got some blur filters if you want to blur some masks. You have inverters and expanders and selectors and clamps and so on and so forth. Natural tab, we've got erosion, which is a pretty important tool. I use it in pretty much all my setups. The other ones are not as important. If you want to learn more about them, just go on YouTube and check up thermal weathering, snow or coast erosions for Worldmachine. Then we'll have a few selectors and converters, but I'm going to go through them, the ones I use later on. Alright, so let's make some geometry. I'm going to start up with doing some basic shapes and show you how to mask some noises. It's going to make sense in a while. So in the generator tab we have this thing called the layout generator. Most people might want to start with an advanced Perlin or Perlin noise because they just generate cool looking geometry right off the bat. Let me just check the resolution. I'm going to lower this to 1024 right there. Alright. And Control B to build your world and do all the calculations and make it look final. Alright, yeah, most people might want to start out with the Perlin noise or advanced Perlin because it looks pretty okay, I guess, from the start. And the other ones basically don't do anything that looks like terrain. But instead, I'm gonna first of all start with a layout generator. Left click again. Then you can make another one by left clicking straight away, or you can right click to deselect it and bring it up. Alright, so the layout generator, what does it do? Well, nothing, as we can see in the preview window, until we double click it in the green area. And we go to this layout view that I hated before, I said. And in here, this is our square, the little cube area. Right click to pan around, I guess. Scroll wheel to zoom, and yeah. In here we can use the box, the circle, the polygon and the line tool to draw shapes instead of just starting out with the basic noise. So for this image and this one, kind of mostly in this image, I wanted to center around a big kind of mountain or a peak, call it whatever you want, in the middle. So I wanted to really control where it was instead of just making something pretty random, because if you would have seen the outsides of this scene, you would have seen that it was pretty flat. It wasn't really a mountain, it was just, this was one of the hills on the mesh. But in this one, I really wanted the massive mountain in the middle, so I really wanted to define the area of it. So to do that, I'm going to use a circle in the middle here. Left click, drag it a bit. Boom, we got a peak. Now, this looks awful, I know. If we right click outside of the area after we've created this and move it over here, we can drag it and move it around. We can also change the fall off size, and if we double click it, we can change the height, the opacity of it. These are basically layers like in Photoshop. But I'm just going to use the max height and max strength, opacity, whatever, yeah. And you can change the fallout distance in here and change the curve in which, like how it behaves, as you can see up here in the preview window. But I'm just going to use the linear one. Or no, I'm not. Never mind. I'm just going to delete this and make a new circle because I can't remember what the hell it was set to. Oh, maybe it was linear, yeah. Alright, I'm going to move this a bit off to the side because I don't like things centered. And this looks weirdly uniform, so what can we do about that? We can go into the left menu here and use breakup. And now when you drag it around, it's going to basically deform the circular area by using a noise pattern, basically. A fractal pattern, really. So I'm going to move it a bit to the side, but not too far. And as you can see in the window, it looks more like a mountain now. I'm going to edit it, higher the breakup scale a bit, just a tiny bit, like 5.3, because I don't want it as noisy, basically. Alright, well, what can we do with this? I mean, it looks pretty bland and boring. Well, I'm not going to use it to generate any geometry at all, actually. I'm just going to use this as a mask. Now I'm going to bring a advanced Perlin into the scene. This is a standard noise generator for terrain, and I've never seen one single realistic looking terrain setup which doesn't use this. So let's have a look at the nodes here. at the layout generator, we have an output for the height field. This is the height information, of course. And then we have a shape mask for the height field as well. So to pass along the height field information, you're going to use this black node output every time. If we left click it, we get this line and we can select where to output it to. I'm going to output the height field, the height information itself, into the shaping guide. So now the layout generator is going to affect how the advanced purlin is shaped, where it's located, where it's where it's concentrated basically. So you can see the resemblance in the preview window up here. But it stretches all the way out in the edges as well, because since this has no information in the edges, the advanced purlin just continues and generates random geometry basically. So then I'm going to use this mask node, the shape mask, and connect it to this mask input. And as you can see now, it looks more like the layout generator's original shape, but it has the advanced purlin noise applied onto it and generating from the noise basically. And that looks way better. Alright, so what can we do with this? Well, we can double click the advanced purlin and we can change the scale, because now it's not very detailed. If we increase it even more, we get basically no ripples or rock information at all. So I'm going to bring this as low as possible without it looking really weird and awkward. So if I put it too far, you're going to see it just spikes everywhere. But I'm going to put it right about there, 2.3 kilometers. Oh my god. I'm going to change the style of the ridges to sharp ridged. This is because we're going to do a pretty harsh environment. I'm going to try to recreate the snow and rock scene because it's the easiest to start out with for me. So sharp ridged is the style of the noise basically, and it works very good for mountains. That should be about it for these settings. I think we're pretty okay. And it looks extremely harsh right now, but we're going to tear it down later on, so don't worry. Next up is erosion. Also talking about the natural filters over here are basically what affects the generated geometry and put some special effects on there. So I'm going to add an erosion. Right click, and I'm going to add the height field input to the output to the height field input. And if I open the erosion, you have two basic erosion methods, standard and channel. Channel is stronger and it gives more control, but it's also really easy to go overboard with it. But I'm using it all the time, so sometimes I want to use a filter to avoid going overboard, and it might be a good idea to put a simple filter on there with a low value, just to be on the safe side, but I'm going to use no filter because I know what I'm doing. The sediment carry amount, I'll pretty much have to show you what it does. The rock hardness is how durable the rocks are to the erosion effect. But if I increase the sediment carry amount all the way to 1 and enable geological time enhancement, which basically just tears and tears over and over again in the simulation process, and I do a build, you're going to see the effect of the sediment carry amount right here. As you can see, the high angle or steep angle rocks are pretty much they still have their detail, and they're not as affected by the sediment carry. The sediment carry gets a lot of strength here in the flat areas with pretty low angles. And it's just, imagine like having a mudslide over and over again over the years, and you're just trying to wear down the environment and just pull everything, every small rock and every detail down with it. So I don't want to go overboard with it, because I still want some detail in there, but since it's going to look like snow, I don't want it to be all bumpy either. So I'm going to go into the erosion again and lower it to about 0.3 something. And I'm going to do another simulation and see what that looks like. Alright, that's a bit better. As you can see, we still have the large flat areas. We also have some pieces of rocks and terrain poking out of it, so we don't have a boring flat landscape anymore. And as you can see, we also regain some of the shapes here in the lower parts. Alright, this is still a bit too sharp, especially on this hill. So I'm going to use a combiner, which can combine two pieces of geometry generators. Now, when adding erosions, you're adding a lot of simulation time. So if possible, use one or two. You don't want to go overboard, especially when you hire the build resolution. Because if you're going from 4,000 pixels to 8,000 pixels, the render times can be increased like tenfold, maybe 50 times the render time or simulation time. So be careful with the erosion, because it's really intense. So you have the first piece of geometry here. I'm going to put another generator. Now what I did with this build was I wanted to have a sphere pretty much as an indestructible comet has hit the environment and just sunk itself into the ground. So I needed the environment to be lowered into the ground around the sphere, because I didn't want it to go straight into the sphere. I wanted to have it go around it. So how did I accomplish that? I used one of these, a Rayleigh gradient, which is almost the same as the layout generator thing we use, but it's straight in the middle if you don't use an offset, and it's just easier to control for these purposes. So what I would do then is I would put a Rayleigh gradient, I will go into the macros, and I would download a crater macro. And these are special nodes that developers have put it on the in the macro library on the Worldmachine webpage, and you can get this for free. I'm not sure if this crater macro was on there. It may have been on a different forum, but you can find another crater macro at the official forums. I'm going to put the Rayleigh gradient height field into this node that says Rayleigh gradient. I'm going to go into the generator, and this needs two inputs, and it doesn't really matter what the other height map is. You could technically use this advanced Perlin and put it straight into here, but it gives more control if you deal with the combiner instead later on. So I'm just going to put an advanced Perlin, or no, a Perlin noise, and I'm just going to go make it real big so it doesn't really have that much of an impact. And I'm going to connect it to this node. As you can see now, the crater has created a crater. That was a weird thing to say. And then you have different methods of adding these two nodes together. Usually average or add usually works the best. And I'm just going to try to create a very, very subtle crater, just to show how I made the other one. And then I'm going to connect the crater macro to the combiner. And an important thing about the combiner is that you generally want to connect the main environment to the top node, to the primary node. So I'm going to connect the height field to the primary input next, the top one, and I'm going to create a macro. I'm going to pull the macro into the lower one. So if I then go into add and pull this all the way to the left, I'm going to have only the top node visible. This works like the Photoshop layers, add, subtract, multiply, and screen, the differences as well. And what I used was add because I wanted both of them to be pretty strong, but I wanted to have control about how much the second node was affecting the first node. So if you watch here in the top left preview window, if I use add and I start pulling in this macro, you can see that it starts to grow a bit. The growing part on the outside is because this purlin noise is higher than the C level, the base level. So actually I'm going to delete the purlin noise, and I'm going to use a constant instead, which is just a flat value. And this won't add anything really. So if I go to add now, it only adds the creator part, since this is the creator now. Add, yeah. And if I put this pretty strong there, you're gonna see how I basically added the creator and then place a sphere. The sphere was added in Cinema 4D later on, but this was how I created the sphere basically, or the creator. But right now I'm going to use instead of the creator, I'm just going to delete the creator, delete the constant, and just use the radial gradient. And I'm going to keep this pretty much in the middle. I'm going to use the Gaussian at a pretty big radius. I'm going to add this into the combiner, and I'm going to put subtract instead. So now it's taking the main geometry minus whatever's in here. So I just want to pull away a little bit on the left side, because I didn't like how high up the sharp ridge over there was. And alright, that's better, a bit better, yeah. And the combiner itself isn't very intense as the erosion is, so I'm actually gonna use another combiner over here, connect this combiner into the main one, top one, and then I'm gonna create some advanced purlin, lower the scale a bit, and also lower the elevation center, so it's not really big mountains but just hills. I'm actually gonna just pull this back up a bit and lower the steepness, because I don't want very steep ones, I just want lower, like a bit of detail. And I'm going to combine this into these bottom slots, and now I'm going to, instead of add and start adding in these things, as you can see it affects all the it affects all of the mesh, basically all the mesh area. Instead I'm gonna select root, and what this does is it basically grows the areas, well, where the roots are supposed to be, if you're talking about a tree, at the bottom and the edges. So it's going to give it a bit of detail. If we do a quick build here while I check my notes. Yeah, combiners, check. Alright, I'm just going to do some quick tweaking and I'll be right back. Okay, so what I went back and did was I went into the combiner and I changed it from root to screen instead. Screen doesn't really make the high parts go higher, but instead it just adds information up to the point where there already is information. So it gave me some lower grounds to work with. Also, I went into the advanced purlin because I really wanted to get rid of this sharp ridge on this left side, because it looked not unnatural maybe, but it didn't fit the look I was going for. So I went to the advanced purlin, and since the purlin is basically just a noise pattern, I can just move this noise around to get a different look. So I went into the transformation, and this is the position of the noise, sorry. And I lower this to 3 kilometers, and I got just a completely different noise output to work with. And this might be a bit low and not as extremely interesting, but I think it's easier to work with from a tutorial standpoint. Alright, now we're gonna check the erosion again, because since we combined the first advanced purlin with the radial gradient and then another advanced purlin, this erosion isn't really doing a whole lot for us right now. So instead, I'm just gonna delete this erosion actually. And one important thing about deleting stuff and undoing things, etc., is that Worldmachine has a pretty weird undo system where it doesn't always work. You see, if I delete this, which I'm going to, so I'm perfectly safe, you see up here in edit you have an undo change command and redo, as in most softwares, but they don't really work. See, if you have a macro loaded, let's say you download an advanced one like the B Core Alpha, and as you can see, this has a lot of settings, and if you set this up exactly as the way you want and it looks perfect, then you just want to take it out of the just put it out of a node if you had it connected, and you just get rid of it, and you shift delete and you try to undo. It's not available. It can bring back some of the nodes, so that's going to be pretty annoying if you set it up and you accidentally delete it and you want it back. But now, since this was pretty easy setup for the erosion, I'm just going to add it again after the combiner, after I've combined everything else. I'm going to pull the high field into the high field, go into the erosion, channeled, rock hardness, sediment carry, time enhancement, and let's do a quick build. So, okay, that's gonna have to look good enough for now. Could do so much more, we don't have time for it. Alright, now at this point, this is where the control freak and OCD in me takes over, and I want to organize stuff. So a really good way to do this is a built-in tool called the grouping tool. You select it and you click and drag in the node view, and you drag it out like this, and now it's grouped. So you can take this group, select it once, and then just put it around, and all the nodes in it will just follow, just like a group in Photoshop or a null in Cinema 4D or After Effects. I'm gonna name this generators, make it green because it matches. Okay. The combiners don't really need a label for now, and the erosion doesn't either. Alright. Actually the erosion does, because I'm gonna use it for the colorizing later on. Alright, let's go into the color methods, color macro, and different techniques. Previously, I've used Worldmachine as a height map generator for softwares like CryEngine, which is a game design software development kit, basically, by the company of Crytek, who made Crysis. Yes, their names are similar. And then you want to make it as basic as possible, and you just want to output a height map and a diffuse map and just slap it on top of each other and call it a day, because you don't need a fancy shading or anything. So you want to have everything baked. What you can do in Octane and Cinema 4D is you can output masks and then use materials that you create inside of Octane or Cinema 4D, and then mask them using the maps that you output from Worldmachine. For this snow scene, that's what I did. The snow material and the rock material beneath it, they're both created inside of Octane, and then I used some masks that I outputted from Worldmachine to just select like where they're going. This one was made differently. This was they made with the CryEngine technique. I just slapped a diffuse texture on it and a normal map on it, and that was it basically. Why would you use a diffuse map? Well, you have a lot of color info, varying color info, that you really want to get from Worldmachine, because you can't easily recreate it with shaders in Octane or Cinema 4D. You could combine a diffuse with a map if you want to use this rock material as a diffuse map as a base, and then you can use a mask to mask a snow material on top of it. But I just output the two in the same diffuse map, and it worked pretty okay since they have the same specular values and stuff. But we're going to look at the colorizer now. I'm going to use a macro that I downloaded called Basic Coverage. Now, if you want to get this, it's called Basic Coverage in the Worldmachine, but on the website in the macro library it's called Basic Splat Map, and it says that it's created by Steven. Let me not get this wrong. Steven Schmidt, but here it's listed that as it's by Worldmachine, like the company itself. I think he's oh god, don't judge me if I get this wrong. I think he's a developer or the creator. I have no idea really. But yeah, if you want to find this basic coverage, it's called Basic Splat Map. And the normal, let's see, devices, colorizer. Yeah, the default colorizer has this gradient setting, and if we hook it up to, now this is our final geometry, and this is a post effect on the geometry. So this is the higher information we will need to use for the colorizer, for the advanced one. If you use a normal colorizer, you just take the latest high field, import it or apply it, and then you just go it down. It has a few presets. The jungle and mountains is pretty okay, I guess. And then you can use this output node called overlay view if you want to preview it, because now before we had proper geometry with the basic shading on it, so we actually had like 3D geometry to show if we went to the overlay view or 3D view. But now, since the final node is a colorizer, we're just getting a flat plane because it's a texture image that is the final output. So we need to hook this into something to be able to preview it in 3D. And this is where the overlay view comes into hand. We can put the texture bitmap output into the overlay input, and then take the height information from the height field and put it into the primary input. And then when we click it, we get the geometry from the erosion with the color from the colorizer combined. We can do a quick build, and there we have some cool textures. Now the problem with this basic colorizer is, as you can see, it's all based on height values. you start out with a green, you go up to darker green, kind of a brown, orangish tone, and then at a fixed height value, you get these like rock kind of material for the cliffs. Now, what if you have rocks down here that you want the same color as these, but you don't want to have everything on that level to be rock color? Then you need to get into some more advanced colorizers. So I'm going to delete the basic one. I'm going to delete the overview. I'll just add it back later. Now this basic coverage needs two inputs. It needs the terrain input and an erosion input. Now the erosion input is, we're going to use this one. And as you can see, we have three output nodes, three outputs down here, called deposition, wear map, and flow map. We're going to connect it to the flow map, because the flow is basically the effect we were talking about before, the sediment carry effect. So the sediment carry and the flow map will be these streaks down the that goes down the cliffs here, which we can then colorize because we have it as a map. So as you can see, it's black because it needs two inputs. So we're going to take the high fill, and instead of taking the high fill from the erosion, I'm actually going to take it from the last combiner, the step before. There's a minor difference, but it's maybe not as noticeable here, but never mind. I like to use the high fill input right before the erosion instead. It gives a better look in some cases. Now, if we enter this basic coverage, we can do a few things. We have a few presets over here. We have some values over here, and we can enter the macro itself. Let's have a look at the presets first. You have Dover, I guess, Grass and Dusty Rock, Pacific Northwest, Sandy Desert, and the one I actually based this one on is the Snowy Dusting. Now, if I press OK and add a overlay, pull the texture, and pull the height, this looks nothing like a snowy mountain. It looks pretty weird, I guess. What can we do about that? We can enter the macro. Instead of sand, which is the basic name for it, we're just going to change this to not a pure white, but an off-white color. And I'm going to use a bit of blue tint in here. So what does that look like? Well, it looks like snow now, doesn't it? Yep. And I don't like this brown tone, so I'm going to change the rock texture to something darker, almost as dark as it can be, but a bit brownish. And yeah, so we'll get a lot of black in there now. Yeah, pretty nice rocks. All right. Now the erosion map is going to have a lot of effect. If I put it up to bright pink just to see where it is, you can see that it affects pretty much everything in this setup because it has a lot of erosion. Now, it's your choice what you want to do with this. You could just try to blend it into the rocks and make it like a dark blue. This one we can diffuse pretty bland and boring. I usually just put it to white or an off-white and even more off-white, and then play with the height cutoff and slope cutoff effects. The slope cutoff affects the sand and erosion, only the sand overlay, depending on how steep the angles are. I usually keep this at about 75% something, and the high cutoff is basically how high up from the water level the snow is, or sand, snow, whatever is going to reach. So I wanted to reach almost all the way to the top, but not to the highest peaks. I'm just going to put it down a little until I see that the top slopes aren't affected anymore. This makes it a bit more easy to see. Yeah, there. And then this slope was what I was talking about before earlier. If you wanted to affect the lower cliffs without basically affecting everything in a height value. So the slope cutoff will control what angles get colored in the rock texture basically. I'm going to pull this down to 0.6 just because I really want to show you what it does. Now, as you can see, even though these rocks are at low altitude, because they have a pretty steep angle, they still get colored by the rock texture. And a few garbage trucks decided to go right by my window, sorry. Alright. Since we have the basic scene here, and this was made in a rush, I'm actually not going to use this one to show you the outputs. Instead, I'm going to use a scene that I've used before. And I'm just going to delete or show you how it's set up basically. So this is the same concept. I'm using one advanced purlin for the base, another advanced purlin to add some details to the outer areas. So those two combined look like this. And then I have another advanced purlin, but a Bladner one combined with this geometry to create something like this. Now, between these two combiners, I put an erosion. That is because I wanted the erosion to appear on the centered like mountain, but I didn't want it to appear on top of the combined elements around it. Because as you can see, the flat areas around it are not as... It's not going to be good looking if they're pretty eroded and sharp and harshly treated as this main mountain. So after the erosion, I combine this with the outer areas, and this is going to be the final height map information. So this is what I want to output as a mesh basically. And Worldmachine has some pretty good output nodes for building mesh information. And I'm going to build this. I'm going to output it as a 4K map just for the tutorial purposes. So it's not going to look super great maybe, but I need to be able to make it run. So since this is the final height field information, I'm going to output this into the primary output of the mesh output. The mesh output you can find either under outputs here, mesh output, and you just drag it in, or devices, outputs, mesh. If you open this, you have a few options, and you have a preview of the mesh here as well. Now, by default, this will have regular mesh triangulation selected. This will become extremely dense and it's going to be hard to work with, almost like nigh impossible. I recommend doing a simple mesh reduction, and this is going to be defaulted to 250, I think. 250 is pretty low res. You can easily get away with 500. You can pretty easily get away with 1000. But I'm usually going for 1500 because I don't want to rely completely on a normal map for the details. I actually want to be able to have some detail already there, especially if I'm doing a sharp ridge one with a lot of details. I'm going to do 1000 just because I want to be able to handle the viewport. You need to specify the output file. I'm going to go to a folder I created. I'm just going to name this mesh object, and it always exports as an OBJ if I'm not incorrect. Oh no, you can actually, no, OBJ is the only one. I also take output file on every build, and I do that on all these nodes because the simulation and build up of the generation, the generators, usually take up like 93% of the simulation time, and then actually building the mesh and the diffuse maps takes like no time at all. So if I want to go back and change something after I've rebuilt and exported it into Octane, I see, oh no, I need to change that mountain, I can just open up the Worldmachine file again. I can change whatever it is. I can just press Ctrl B, build, and it will update all the mesh files and the diffuse map files and every output I have. So I'm going to always check output file on every build. Press OK. Then we have the height output. So I'm using this to build a height map. This could be used for masking, I guess. I rarely use height maps in Octane actually, but it could be good to have if you need a mask and you don't have anything else available. In this has all the height range in it, so it's always nice to have. I use TIFF 16-bit for all my diffuse map files or texture files, and as always save the file every time the Worldmachine is built. Press OK, and you need to connect the height field to the height information in the final mesh terrain generator thingy. Then the overlay view, mumbling coming here. It's basically just the same as we used before. Has the color information from the texture combined with the mesh, and it creates an overlay view which we can preview right here. Now, as you can see, it went really quick, stopped at erosion for a while, and then really quick for the mesh and diffuse again. So the erosion is probably always going to be the most time-consuming piece to calculate for the software. And this is what it looks like right now. Let's go back into the device view. I also have a select slope and a height output file. The select slope is just so that I can have a mask that where I can only affect the I can use it as it is and only affect the steep areas, or I can just invert the mask in Octane or whatever software I'm using and select the flat areas. And I'm putting this into a height map and not a bitmap, because you can only use it as a height map output with the select slope thingy. I'm also using a splat converter, which is a splat map, and I'm only using it with black and white right now because I want to select the erosion flow map and create a bitmap output of that. You could, I guess, use something else instead of a splat converter, because a splat converter isn't designed to do this naturally, but it just works. I won't go into detail with it because I don't understand it myself. Then I have the diffuse map, basically the bitmap output, and I've connected this RGB input to the final colorizer output, and this is just gonna create a, as I said, a diffuse map for the terrain. What's good about the colorizer input, the colorizer node that I showed you, the basic coverage node, is that it doesn't have any light baking in it, so I don't get any shadow or light information. This is just like, this is basically an albedo map technically, instead of a diffuse map, because it doesn't have any baked lighting in it. But yeah, I'll still call it the diffuse map. Then I have a normal map maker. Now the normal map maker can be found underneath the converter tab and normal map, and you connect the normal map input to the terrain output. So the height information is connected to the normal map, and then you have to connect the normal map to a bitmap output because you actually want to make an image out of it. And as always, TIFF 16-bit output file on every build, and you need to specify the output file. Same thing goes for all the other bitmaps and image files. Now, once again, I just switched scene files because the last one I used as an example to show you how correctly set up Word looks like and what the outputs do. Sorry for jumping back and forth, I'm going to confuse you guys, but yeah. I wanted to use a word that I haven't made an image out of yet because I don't want to repeat the final product. This is a snowy mountain. I based it on the idea of this one, but it's going to use a diffuse map instead. I'm going to try it and see what happens. Setup is the same, but I haven't selected any outputs yet. So I'm going to really quickly do a mesh, bitmap, height, and a normal. Okay, normal goes to the final height information. Saving this as normal. Output in a rebuild. Bitmap is going to be straight color information. So here I actually use a different coloring macro. This is another macro that can be downloaded from the website. It's called, this has a proper name for it, coastal overlay, and you can find it in the macro library down here. I'm going to connect the color to the bitmap, and we have a flat diffuse map. Mesh output, connect that to the final height information. Simple mesh reduction. Oh, so to 256, of course. I'm going to set it to 1000 because reason. I'm going to specify the file, replace the mesh object file, output file on every build. Okay. And this is pretty much all I'm going to use right now. I could go advanced and use the slope effects and everything, but I don't really think I'll need it. Or actually, I could do that because I have a select slope here for the rocky areas. I'm actually gonna do this Select slope, and I'm gonna pull can I put a hide output? I think I can, yes. So as you can see, this document has a bit more resolution than I had in the last one, and the build time on the layout generators, the noise, the terracing, which I didn't go over earlier, the combiner, they all go really fast, like 3 seconds, below half a second. And then we get to the erosion, which takes a hell of a lot longer. So I'm actually going to pause this and get back when it has calculated it. Okay, so as you can see, the erosion, I had 2 erosions, which took up most of the time, and the total simulation time was 22 minutes and 48 seconds. And that's for a mesh with a resolution of 4000 pixels, basically, for the texture maps, and yeah. So let's see what we got. We have a Cinema 4D or an OBJ mesh. We have a diffuse map for the coloring. We have a normal map for some details, and we have a slope map where we can select the steep slopes to color them. So, next step, importing into Cinema 4D and setting up the geometry for Octane. Now, in the later or in an upcoming version, there will be an option in the mesh output node to fix rotation issues, etc., etc. But so far, every time you import the OBJ into Cinema, you will see that the mesh, which I imported 100 centimeters, is flipped. So we need to fix that. And I put this 100 centimeters because I experimented a bit and I found that keeping the geometry the same size, almost the same size as a basic Cinema 4D cube, works the best for depth of field and detail, shadows, renderings. So the first thing I want to do, just for comfortability reasons, is to fix the axis offset and centering the mesh, basically. So I'm going to enable the axis move thingy, and I'm going to move it roughly to the center of the object. And then I'm just gonna snap it roughly to the center. And rotate it. And now we're gonna have a look at the mesh density. Because we used the reduced value of 1,000 maybe, and this is the density we're going to end up with when we export the geometry into Cinema. And this is fairly okay. I usually go higher, I usually go double at 2,000 or 1,500 if there aren't a lot of details, but for this tutorial I'm going to go with 1000 just because it's an okay density, and we're going to have a normal map and diffuse map to hide most of it anyway. So I'm going to go back to Gurad shading, and what I would do if I would have made a crater would be to just add the sphere, scale it down to about 10 or so, just place it into the position of the crater, and then create two materials, one yellow, one blue, just to differentiate them and make it easier to find. And one thing we need to check is the UVs, that they're all set. Because sometimes, and I don't know why, when you export the geometry into Cinema 4D and then bring it into Octane, if you're going to use a diffuse map or any mask or map at all, you're going to find that the texture maps are really like extremely stretched and don't fit at all. So you want to make sure that the UV maps are applied correctly. So for that, we're just going to try to apply the diffuse map and see how it matches up with the geometry. And now it looks like it worked just fine for us, if I'm not mistaken. No, it matches up perfectly. Nice. So yeah, and if you export if you have that problem with the UV map and you need to correct it manually by going to, let's say, setting it to cubic mapping or something instead of UV, and trying to correct it manually and disable tiles and adjust the offset and stuff like that until it looks good. What you need to do then in the Octane, if you're going to export into the standalone, you need to open the export dialog and check collect all texture images, because then it will create a new UV map and it will keep the position of the textures relative to the object, and you won't have to readjust them inside of Octane again. So it will keep that information. But for now, we're actually not going to export anything other than the actual objects into Octane, because we're good to go. So I'm just going to hit render and let it export to Octane. So if you're new to Octane, it has a quite different setup, behaves differently than Cinema 4D does, obviously. I'm actually going to save this project just in case we need to open it again and re-export something. Alright, so we're in Octane. We have our object list onto the left, and we have the nodes down here. And apparently it actually brought the texture with it, even though I didn't check it, which is weird, but good, I guess. Alright, we're just gonna set up a render target and a thin lens camera, and we're going to talk a bit about the lighting, but we'll have to do it in conjunction with the materials. So since we don't have any baked lighting into the diffuse texture, we can light it however we want. And I'm just going to pull in a daylight to begin with, or I'm going to put in both a daylight and a texture environment just to tell you how they differ and what you want to do with each one. So if you plan to light it by an HDRI image, just go into texture and select RGB image and open the HDRI that you have downloaded, created yourself, whatever. And if you select it and load it, you're gonna notice that the brightness and everything is gonna be a tad bit off. And whenever you use an HDRI with a proper render engine, you have to set the gamma to 1 instead of 2.2 because it's not an 8-bit image. And if it's still too bright, instead of messing with the power straight into the texture, adjust the power down here instead. But as you can see, it's giving me no hard shadows, and it's just doesn't fit because it's taken in an urban environment with not a lot of detail in it. So I'm just gonna try a completely different one. And with an HDRI image, the benefits of using those is that you get a bit of soft and more natural, or not natural, but not a linear light. So it might be good in different looks. For this image, I actually used an HDRI. And in this one, I used a Octane sunlight. And the difference, because I was using a sunlight, is because I needed the sky to be visible in the reflection of the sphere. And the HDRI sky was showing up as pretty ugly, and it didn't exactly fit the reflection. And I didn't want to do the compositing in After Effects and just replace the sky, because it would look weird and it wouldn't match the lighting with the shadows and the look of the sky, etc. So I just went with the sunlight instead because it fit the environment. It's a snowy landscape. It has just a blue, clear sky and a harsh sun, so it just worked. Here, since we don't actually see the sky or the sun or any reflection of it, we can just use whatever we like, and I chose to go with a HDRI image instead, just because I like the color that it produced onto the very dull color scheme that I had on the image itself when I exported it. And for this image, since it's a snowy landscape, I think I'm actually going with daylight instead of the texture environment. But first, I just want to show you that this third one is an HDRI that is not at all of a big scene or something. It's just a free HDR map that I downloaded that's taken at a dock or something. And as you can see, if you zoom in, just like if it works, it works. If you put up the power and it looks good, don't worry about the environment, what it looks like. Alright. But I'm going to plug in the daylight instead, and I have some basic settings that I played with earlier that I'm just going to copy, going 5, 6, 14, June or July, whatever it is, I don't care. Offset 0, and let's do something like something like. Oh, and I also completely forgot to remove the sphere, I now notice, because I am blind and stupid. So let's actually just re-import, since I haven't done many changes yet. And if you go into Cinema and you want to set up your sun there, and you feel more comfortable working with the built-in sunlight that Cinema offers, in the Octane export dialog, you actually have an option to just export the sunlight data out of Cinema 4D into Octane. So we could actually do that just for show, since I messed up. And There we go. So let's do that. Let's set up a sunlight. Display shadows. And it's 7 o'clock in the morning here, so it's pretty early and there shouldn't be any light. Yeah. So if I now would just like to export this, I would just go into plugins, Octane export, and check export sun direction, select the sun as a light source, and do another export into Octane. It's going to calculate for a while to calculate the sun's position and color and blah blah yada yada, but it will load pretty quickly. And as you can see, we get pretty much the same look as we had earlier. And I think this is almost the same settings as I used before. But I'm still going to recreate it into data because I need to put it into the render target. So I'm going to put in another thin lens camera. And let's do that again. 56, 14, or that actually, never mind. And just adjust this to a afternoon setting. And what we could do is just set this to 6 o'clock and then minimize sun direction and just rotate it on the north offset axis, which is basically just rotating the sun around the mesh. And I actually like the shadows it casts kind of there, so I'm going to keep it that way. Now I'm going to go into the scene, and the scene still has old sunlight, so it's confusing. And this is the material of the geometry. And all I do here is, I usually, as the diffuse image, I usually set up a mix material. And for the first material, I put the diffuse image on the bottom. This is confusing for me speaking and doing this at the same time, sorry. The diffuse material there, I put a normal map both in this and in the second material. And then instead of using a flat amount, I'm going to show this as pink or red. Pink is better for visibility to see where it blends. Instead of using a slider for the amount of blending, I'm going to try using an RGB image and using the slope map data, or a height map if you prefer, but this is a slope map to select where the material should blend. So as you can see, the slope map makes the second material shine through everywhere except for where the steep slopes are. So that's the benefit of having a slope map, even though it's pretty inaccurate as you can tell, but it doesn't matter when we're going to put white there. That's the benefit of outputting multiple different maps. Even if you don't know how you're going to use them, they might come in handy anyways. And reset the gamma to 1 is usually a good idea. Set the second material to, now let's keep it that way for now. The first material will be the rock material. So I'm going to put a glossy material actually. I'm going to keep the diffuse as the with the image from Worldmachine, and the specular I will keep at just full power, or maybe like 0.72, roughness at 0.03 or something, just because just because I don't know the correct wool values and I don't want to research them, so I'll just go by what looks good basically. And for the second material, I'm gonna still use a gloss material. I'm gonna put the roughness up almost to the max basically, because you see we're getting those nice reflections, which are just basically highlights of the environment itself. And if we look here through the render target, it will really go with the snow when we change this from pink purple to a very faint, either very faint blue or a very faint orange, but I think a neutral or blue would look better. Yeah. Let's just go for neutral. White. Then what I do after that is just zoom out to get a scope of the area, see what looks good, what camera angle we could use. I'm not going to use this camera angle because we have a lot of blotchy areas because the masking was pretty sloppy. So instead I'm going to find an area with small details which aren't crazily affected by the masking. So I like this area in the middle here. So I'm going to try to find an angle. Also, this setting, the orthographic setting in the camera, the thin lens camera, is a pretty easy way to just get that miniature look. If you're having trouble like get the camera to maintain the area of the geometry within the frame, just check orthographic and you get both a nice look for a tilt shift image, and you'll still keep the geometry in the frame. So that doesn't look too bad. I'm just going to change this to 35mm and an 85 lens, or I could even go for a 200mm lens and go for the real like tilt shift look. And if we just leave the f-stop at 3 or something, we should be able to just get a nice look just based off of that. After that, I'm going to change the resolution later on. Sun is already dealt with. Let's see if I've forgotten anything. Yeah, let's go to the kernel. Max samples depends really on how your materials behave. If they're not particularly glossy, if the reflections are pretty sharp, you can get away with low samples. If they're blurry, you might need to put them up a bit. I usually go with like 500 to 1000 max, and then I'm gonna use a filter size of 0, or 1 technically. Lower the rail epsilon to minimum, higher the ambient occlusion to the top. Just go wild with the settings. This is not accurate, I don't care. Also just bump up all the depths, because this is not an particularly advanced scenes, so it's not going to hit the render times that bad. And I like to live on the... Yeah, let's go 500. Yeah. Now the filter size is going to leave a lot of noise, basically hot pixels. And in the imager, what you then would do would be to keep the hot pixel removal at 1 or at 0, I mean, and it would pretty much try to take out those hot pixels. Now that will make the image less sharp, and you don't want to lose all that sharpness. So what you could do is do a quick render, just restart the render, and while it's still at a low sample rate, you can just save an image right here, because it hasn't actually found those hot pixels yet. You can save that, then combine it later in Photoshop with the high sample image to hide those hot pixels. It's a sloppy fix, it's a dirty fix, and it pretty much only works in still images, but it's a fix nonetheless. I like to wait with post-processing to last, just because it's post-processing and you shouldn't base any judgments on top of the post-processing. So for the imager, I'm going to output this as a linear color space, but you see that the contrast goes really high. So what we need to do is increase the gamma, and this will, I will just put it up to 2.2, and this will in combination with the highlight compression create a pretty flat image, and that's okay because we're going to bring in After Effects later on for color correction. I'm just gonna check that the vignetting isn't extremely high, and it's not, so I'm gonna go 0.3 as it was. Usually you could go even higher with the gamma, but it's not worth it. 3 max, because you really don't want to just introduce a lot of noise into the black areas. But I'm gonna actually output one at 2.2 and one at 3. Then I'm gonna see which one works the best. But or just go in middle ground 2.5. Yeah, that works best. I'm gonna up the resolution. 1080p, and I'm gonna just go wide because we're gonna downsample this. We're gonna super sample actually, so we're first gonna render it at 4551 by 2560, and then we're gonna resize it in Photoshop. I usually just output them at 4551 by 2560 either way without downsampling. But that's when I do them with 8K textures, and I spend a long time really caring about the details and the masking and the sampling stuff, and yeah. So I'm just gonna let this render. I'll pause the video and I'll get back when I have outputted the image file. Okay, so I'm actually not gonna go the full way to 500 samples. I'm actually gonna stop it at 175. You might think, well, isn't it going to be noisy? Isn't it going to have a low quality? And I tell you that doesn't matter really, because what I like to do, and you might not agree with me, but I don't mind because that's your opinion. Is trying to emulate a film stock, basically. So if you don't know the difference between film and digital, is that a digital sensor has pixels and a film sensor has, or a film sensor a piece of film is has a photochemical process, so it's grainy, and the noise isn't square like pixels are. So a noisy digital image will have noise that is square and ugly, like Octane outputs, because it's pixels. I'm going to repeat that several times. But an analog image, if you scan it, the noise won't be homogenical. It will have differences. It will have like a bit of character, maybe, if you wish. And I'm going to try to recreate that in After Effects to give it some nice colors, and a side effect, which is a positive side effect of that, is that we will hide a lot of the noise that comes out of Octane. So what we'll do is import the output file into After Effects, create a new composition, and we exported it with a linear color space, and we use a very high gamma, and we try to give it we use the highlight compression and the exposure to give it as low contrast as possible. And that doesn't make sense right now, maybe, but it will in a second. But first of all, we're gonna apply a new adjustment layer, and I'm going to use a plugin called Film Convert. And Film Convert is a fantastic plugin that is just magical, and it will just boom. It adds incredibly high resolution scan film stock grain to the image. I don't know how good it will show in the video, but in the final output image, which I will export, the fine grain will definitely show up. And it will hide almost all the noise in the out of focus areas, and it won't look artificial. It will look pretty damn natural. And what this also does, it pulls down a bit of the saturation, and it clips a little bit of the highlights and compresses the shadows, but we're still not losing that in information. So now we can add another adjustment layer, search for a LUT or a lot or however you want to pronounce it, add it to adjustment layer, and we're gonna find a LUT file which I have previously downloaded, and you can find these files in a lot of different places. You can make your own presets, LUT presets. There are some basic ones in Photoshop. If you go to Adobe Photoshop and I think presets, yeah, and in 3D LUTs you have all these LUT presets for emulating different looks, basically. So you can just go for horror blue, and it will emulate a horror blue color grading, basically. And these LUT files are meant to be applied on a log color space image, which is really flat, because you want as much information as possible before you actually color grade. So you when you're filming, you output the image as flat as possible. This is a good image to explain it. So here on the right side, the image has a low contrast, but it has a lot of shadow information and highlight information. Then you apply a LUT file to it, and it applies a bit of contrast and color grading and everything. It's a very easy, lazy, good-looking way to color grade. and some color grading experts might argue that it's not good, it's not a correct way to do it, but in my opinion, if it looks good in the end, who cares how you made it? So I'm gonna choose from a few files that I put in this folder earlier on. This is a standard teal and orange boost, basically, that you've seen over and over again in the Transformers movies. This will boost the highlights, put a lot of blues into the desaturated areas, and in the skin tone areas it will boost the oranges. This is not what we want. I'm gonna go through the other ones. This is a pretty dull and flat grade. I don't think it will suit the image. This is actually a LUT file. I think this is a LUT file which make the image even less contrasty or give it even more of that dull look that we applied in Octane. Yeah. So if you already have an image which is contrast rich and you can't go back into Octane and re-render it and output that low contrast look, you can still kind of save it by first applying this type of LUT and give it an even lower contrast. Do another adjustment layer, another LUT file, and then go with the final that you want to use to color grade it. And it will look slightly better because it won't, if I disable this previous one, it will look very harsh and very intense. But here will be a lot smoother and it will be natural. I'm going to use a Kodachrome LUT, I think, for the final image. I might have a look at the fourth one as well just to see how it looks. This is another low contrast one, but it also raises the level. I like that actually. I know, I'm strange, but I like stuff and deal with it. So the blacks are crushed and the highlights are not clipped, so we're okay. Now, someone in the Reddit thread mentioned that you might use a displacement map instead of or in conjunction with a normal map, and in this case that would be a good idea, because as you can tell, if you look at the textures on the rocks, they're very flat because you don't have a lot of erosion on the rocks themselves, especially over here. You can tell it's just a texture on top of another texture or mixed with another texture. If we would have had a displacement map that was limited to where the snow was, we could actually make the snow rise a bit above the black texture and make it look like the snow was actually lying as a bed of snow on top of the rocks by displacing it a few centimeters upwards or something. So we could have done that, but for the purpose of this tutorial, I thought I'd just save that for later because this is already running long. And what you could do, the sun is now out of sight. What I did in this image was I added a extremely subtle lens flare-ish. You could do that into this image as well. I'll just show you how I did it, even though it's not accurate, but I don't mind right now. So I apply this to the base image before any color grading or color correction. It's a plugin called Optical Flares. You probably know of it if you've done cinematics or title animations or stuff like that. And you apply it to the base layer, and it will go black, and you go into options, and you'll be able to pick a lens flare. And these are actual, like, some of them are set up as an anamorphic lens flare, so they will get brighter when they are at the edge of the screen or if they're at the center of the screen. so they will actually react to where in the image they are. So they're actually pretty good lens flares. I'm gonna make this a bit warm, and I'm also gonna add a lens texture. I want it to be that strong, but it doesn't matter because we're gonna tone it down anyway later on. So I'm gonna go for grime or messy, but messy looks good. I'm also gonna increase the illumination radius because I want it to be visible all over. And I could even increase the brightness, and it looks weird now, but you're gonna understand it later on. Actually, I like spastic. Looks like someone has touched the lens and it's all muddy and you're out in the rough weather in a helicopter or something. Yeah, let's do that. And since I'm just going to disable this effect really quick, since the sun was off screen, I'm going to pretend that this lens flare actually is off screen. And it just shines into the image a little bit to cast a glow, because that can still happen. And I'm gonna, yeah, like that. And then you change the render mode to over original, and it's very subtle, but I guess it works. Or it just looks terrible and we shouldn't really skip it. Let's add a curve layer just because the contrast needs to be increased a little bit. Gonna pull down the shadows quite a bit. I'm gonna try to hide most of the artifacts, basically. That's pretty okay, I guess. Yeah, so let's add a really tiny bit of sharpen on the output before the optical flares. Something like 20. Yes, very subtle. It's not supposed to be strong. And then we can, just for the hell of it, let's see if stacking another LUT file would be a good idea. I'm wasting a lot of time, but I don't mind. What happens if we put a Kodachrome on top of that? Could work if we just pull down the opacity a bit. Maybe pull it up a bit. Alright, it actually has some nice contrast. And since we have this lens texture on top of the image, we get these small specks over and over. Over here we have some RGB, some halo artifacts, and stuff like these will actually help your image look more trustworthy, even though this is a very sloppy one. Specks like these, small cracks in the glass or dust on the glass of the lens, or stuff floating through the air and things like this, will just add some believability to your image and make it, I don't know, subconsciously believable. So I'm just going to do a final output here. Just going to output as a TIFF file in the Worldmachine folder, and that's it. Thanks for watching. The image file will be uploaded to Imgur, I think, and linked in a comment in the Reddit thread, most probably in the YouTube description box below as well, just so that you can check out the full resolution image and check out those grainy details and lens flare specs that I was talking about. Yeah, I hope you learned something. If you have any questions, just post them in the Reddit thread or in the YouTube comment section. If you have any feedback to my crappy mic, my extremely lengthy duration of the tutorial, or just general sloppiness, just throw any feedback at me. I can handle it, and I really appreciate it because I want to improve. So thank you very much for watching, if you're still with me right now, and goodbye.